First, the boundaries. You want to go 0.5 below 11, so that's 10.5, to 0.5 above 29, 29.5. 0.9 below, 29.5, to 0.5 above, 48.5. Notice that the 29.5 overlaps from one to the next, and continue in that way. Next, we'll find the n. To find n, you add up the number of frequencies. This frequency means there were 11 items in the class from 11 to 29. There were 20 items in this class, and so on. So we add those up, and we get 100 for n. Next, xm. That's the midpoint. In order to find the midpoint of a class, you add the class limits and divide by 2. You average them. So 11 plus 29 divided by 2, which is 20. I'll complete those now. Next, you find f times xm, the frequency times the midpoint, for each row, 11 times 20, and so on. Be careful on this step. To find f times the midpoint squared, you need to type into a calculator 11 times 20 squared. You can't just square this number. So 11 times 20 squared is 4,400. Double check that you have the right numbers in this column. You'll notice I switched colors so that I can use colors when I do my formulas. So now I sum the f times xm column. That's this column. I add them up. I get 5,344. And I add up the f times xm squared column, getting 313,106. Be careful that you don't forget the mean. The mean sometimes gets forgotten. So go find the grouped mean on your important formulas sheet. Write it down. The mean of a group distribution is the sum of the f times xm's, so 5,344, divided by n. Our n is 100. Round to the nearest tenth, which is 1 decimal place beyond that of our data. There's our mean. Don't forget about that one. That's missed a lot because it doesn't get practiced as much. So go look for that in your formula sheet. To find the variance, we'll just find the standard deviation and go back one step. So next, I'm going to write out the formula for the standard deviation of grouped data. Take a minute to look at where all the pieces fit in. Then, that comes from adding up the frequencies. Look at this, the brown number here, the sum of the f times xm squared. It's actually the second column, the brown number, minus the red number squared. So you actually have to square that number, 5,344 squared. So notice that the order is a little different, and that you actually have to square this number, but not this one. So next, I'm going to write in those numbers. Again, take a look at where those numbers fit in. Are you putting your numbers in the right spots? Is this one going here? This one going here? This one has to be squared. Next, I like to simplify the top and simplify the bottom on my calculator. If you like to do it a different way, that's fine. Also, if you like to just do this on your calculator, that's also fine. Then I divide these two numbers. Notice I haven't taken the square root yet, so I keep writing it. And then I take the square root, rounding to 1 decimal place. Since that's 1 decimal place past that of my data. There is my standard deviation of a sample, my S. So my S is equal to 16.7. Now I just go backwards to get my variance. My variance is the standard deviation squared. So I can either square that number or else go one step back in my calculations and see that it's 278 for the variance. That's standard deviation. Again, you would be allowed to use your calculator to come up with these numbers without going through all of the work. But if your exam asks for the table to be filled out, you would need to fill that out in order to receive full credit. For these problems, make sure that you get very familiar again with your formula sheet. Look at your numbers. Suppose that a student scored a 91 on their exam. So that was their score. So that's our data value. That's our score, our X. On an exam with a mean of 88, so 88, that's the X bar. Be careful. Sometimes on tests I switch the order of these numbers, so it's not always the first one minus the second one. You have to look which one is the student score, or the data value, which one is the mean. And the standard deviation is 2, so that's S. Go on your formula sheet, find the formula under Chapter 3 for z-scores. To find a z-score, my formula sheet says I take x, the data value, minus x bar, the mean, and divide by s, the standard deviation. Our x was 91, minus our mean was 88, divided by our standard deviation was 2. I punch that into my calculator, 91 minus 88, enter, divide by 2, and I get 1.5. The student's z-score was 1.5. That means they scored above average, because it's positive, and they were 1.5, 1.5 standard deviations above the mean. Number 22. The average number of textbooks in a professor's office is 16. So the number of textbooks, the average, the X bar, is 16. And the standard deviation is 5. The average age, so we're looking at number of textbooks and then we're looking at age. So the age, the average is 43. So X bar, average, mean is 43. And standard deviation, S, is 8. Which data set is more variable? When you ask that question, you are looking for coefficient of variation, C-var. Which one is higher? So you go to your formula sheet and find the formula for coefficient of variation, C-var. To do that, you take the S divided by X bar times 100. So we'll find the C-var, the coefficient of variation for each of these. The texts. Standard deviation divided by X bar times 100. And you get 31.3%. That's the coefficient of variation there. Over here, for the age, standard deviation divided by mean times 100. Punch it into your calculator, 18.6%. So the higher percent, the more variable one is the number of textbooks. Chebyshevs. So let's see. First, let's tell what information we're given here. The average cost of a car rental is 32 cents per mile. So average. So when I see average, I think mean. So that's X bar. X bar, the average, is 32 cents. The standard deviation, the S, is 3 cents. Chebyshevs tells us that 75% of data will fall within plus or minus 2 standard deviations of the mean, 2 times the standard deviation. So to find that 75%, I add on 2 standard deviations to the mean, and I subtract off 2 standard deviations of the mean, and then I'll have my upper and lower bounds for that 75%. So I take my mean, and I add on 2 standard deviations, or 2 times 0.03. So 0.32 plus 0.06, which is 0.38. So that's my upper bound. And then I want 2 standard deviations below the mean. 0.32 minus 2 times 0.03. So 0.32 minus 0.06. And I get 0.26. So that's my lower bound. So Chebyshev's theorem tells me that 75% of all the car rental 75% of the car rental cost per mile will be between 26 cents a mile and 38 cents a mile. The number of hours of 11 part-time employees working at the Superior Supermarket during the week before Christmas. So these are amounts of hours. We are supposed to construct a box plot and a stem and leaf plot. I'm going to use a new sheet so I have some more room. My first step in making a box plot is to order my data. The next step will be to find the 5-number summary. 5-number summary is low, Q1, median, Q3, and high. And I need that in order to make the box and whiskers of my box plot. I go out of order when I do this. I start with the low value, 16, and I do the high value, 38. Next I find the median. Which one is in the very middle? Looks like this guy is, 23, okay? Then, so he's my middle, that's my median, 23. Then I find the median of the bottom half. That's Q1. So like the cutoff for the bottom 25% of our data. So my median there, my middle number of the bottom half is 19. And then Q3, quartile 3, the third quarter of our data, that's the median of the top half. So the median of our top half looks to be 36. If you're unsure about that, you can always use your calculator to figure out your 5-number summary. This is called a 5-number summary. Once you have that, you can make your box plot. When you make your box plot, you want a box that shows the middle 50% of your data, or from Q1 to Q3. So I'm going to make a line here for Q1 at about 19. And then up to 36, that's my Q3, and I make a rectangle, a box. I put a line at the median at 23, and I label these. So Q1, median, Q3. That's my box. Now I do whiskers out to my high value and label it, and down to my low value and label it. There's a box and whiskers plot. Low value, high value, Q1, median, Q3. I'm going to make a stem and leaf plot for the same data. Stem and leaf plots have the tens digit listed. So we have some that start with 10s, some that start with 20s, and some that start with 30s. And you make a vertical line. And then we're going to put 16, 16, and 19, just the ones digits with no comma. So 6, 6, 9. Then look at the 20s. 20, 23, 23, 27. So a 0 for the 20, 3s for the 23s, and a 7 for the 27. And then the 30s. So this shows that I have a 16, 16, 19, 20, 23, 23, 27, and so on. This is a stem and leaf plot.